Advanced Financial Modeling, Topic 7, Option Valuation and Hedging, Learning Objective Number 6, Compute hedged and unhedged cash flows using options and forwards. So we're going to use an example here of using options to hedge positions, just like in the last previous lecture, Topic 6, we did hedging with forward contracts. Like forward contracts, options can be used to hedge the purchase or sale of an asset. You would hedge a purchase of an asset using a call and hedge the sale of an asset using a put. Unlike forwards, options require an upfront cost, also known as the premium or price, and option payoffs are asymmetric, meaning zero if the option is out of the money or at the money, and positive payoff if the option is in the money. How we write that in Excel is the call profit is the max of 0, ST minus strike times Q, and the cost of the option is C times Q, where C is the call premium. The put profit is the max of 0, X minus ST times Q, and the put premium P times Q is the cost of the option, so those are the profits. So these are very similar to the forward payoffs. Remember, if we did a long forward, it was just ST minus F times Q, and F minus ST times Q for a put forward payoff. So we're going to use both those equations in the next lecture, or the next model. So here's a model of ExxonMobil hedging the sale of oil. So suppose ExxonMobil wants to hedge the sale of crude oil at one of their facilities in 1 year. So 1 year from today. They expect to produce between 7, that's the minimum, and 10 maximum barrels per day. They plan to cover the minimum of 7 million with these by using a forward contract, a short forward. And then we're going to use 2 million or 2 million of the hedged quantity will be hedged with an option, an out of the money option, and then 1 million will be unhedged. So that is 7 million will be covered with a forward, and then another 2 million with an option, and then 1 million is unhedged. So some risk is going to be left over. So we're going to assume crude prices are normally distributed and barrels produced by ExxonMobil are uniformly distributed between 7 and 10 million. So let's get to the model and fill it in. So here are my parameters, and we'll go ahead and start calculating the simulated oil prices and simulated oil production. So we're going to use the random walk model for oil prices. That's the spot price of oil, which is 76.55 times 1 plus the expected appreciation, 6%, plus norm S inverse Rand, times the standard deviation, look at that formula there. That's one spot price of 76.55 times 1 plus A5, which is the expected appreciation, plus that random Z, norm S inverse Rand, that normally distributed random Z times the standard deviation. So every time I hit F9, I get a normally distributed price of oil. And then the simulated oil production using a uniform distribution. From the last week's topic, we know that when you do uniform distributions, it's the minimum plus Rand. That's that 0, 1 random number times the difference between max and min. So again, that's the minimum plus Rand times max minus min. So every time I hit F9, I get a number between 7 and 10 million. So my unhedged revenues are the simulated oil production times the simulated oil price. And every time I hit F9, I get a new random production quantity and a new random price. So it looks like their revenues going to be in the, $700, $800, $900 million range. So what if they hedge, however, getting a forward contract on 7 million, a short forward, a put option on 2 million. All right, so what are their hedged revenue? Well, I'll start off the easy one. It's the unhedged revenue plus, let's do the payoff of a forward. That's going to be a short forward, that is. That's going to be F minus ST. The forward price is 80.25 minus the simulated price of oil times the 7 million quantity. So that's my payoff of the forward contract. So I'll make that a little bit bigger. Again, that's unhedged revenue plus the forward price minus simulated spot times the quantity. I'll then put in my payoff of the option, max 0, comma, X, which is the strike price. We'll use a $75 strike in this example, minus the simulated spot price, 92, or in my case 92, but you'll have another random number, times the 2 million quantity. And I'll hit enter so you can see the formula so far. That's maximum of 0, X minus ST times the 2 million. And the last thing, I need to subtract off the cost of the option. There are 2 million options times 472, which is the option price according to Black-Scholes. Notice on Black-Scholes I have the BS put function, and I assumed a volatility of oil prices of 24%, current spot price of 75, no dividend yield, and I have a risk-free rate in there, and I went ahead and calculated the Black-Scholes price of a $75 put option on oil, 1 year maturity. Okay, so I think I'm all set here. Now hit every time I hit F9, I get a random unhedged and a random hedged revenue for ExxonMobil. I do have a sub here, a macro, that collects the unhedged and hedged and puts it in these cells here. I've hidden a few rows, so it's going to be unhedged are going to wind up here, the hedged here. So let's go run that. Alt F8, ExxonMobil, run, and this is going to take a while. Mostly because it's a really big workbook, and every time you paste a number in Excel, it recalculates every number in this workbook. So you don't have this trouble in exams, but you do have this problem. So let me get back to you in a few minutes as soon as this runs. Okay, the simulation seems to have run, so let's see some of the results. Again, so I have a column here of 10,000 unhedged revenues, a column here of 10,000 hedged revenues. Let's go ahead and take the average. So an average of 688 for unhedged and 683 for hedged, so about the same. But that's not why we're doing a simulation. We don't do it just to get the averages. We want to talk about what possibly could happen. What's the 5% highest and lowest? And then we're also going to calculate what's the probability that the revenues could be less than 500 million. Maybe the management determined that at $500 million, they would say lose money, have negative profits. So they're really concerned about that critical value. So we can do a large function. Large. Go ahead and put in the array, comma, 500, the largest 500. So it looks like revenues could have been 978, but with hedged 800. We can do small. So I'll just put in the array, comma, 500. So if there's no hedging, it looks like the revenues were between 417 and about 980. With this hedging scheme, hedging 90% of your exposure, 70% with forwards, 20% with options, 10% unhedged, you're now between 570 and 809. And in this one, we'll say this is the critical one. Management is really concerned that revenues could be less than $500 million. So let's do count if, put in the array, comma, double quotes, less than 500 million. And that'll count how many observations are less than 500 million. I'll divide by 10,000. And it looks like there was a 13% chance in this case of saying having negative profits. Now, with the hedging scheme, there's a 0% chance. Well, maybe it's not zero. Let's add some zeros to this to see. No, it's a 0% chance. There's no observations less than $500 million. So that's great. So this is the advantage of hedging. You can see their revenue is unchanged. Their mean revenue is unchanged, but they've drastically reduced the volatility of their revenues. And 13% was the probability of saying losing money. Now it's 0. So how could you change this model? Well, this could be a model for an oil user, say a purchaser of oil. If I did that, I would need a call option price. And when I calculated this over here, these would be costs, and the simulated production would be negative. And when I did the payoffs, it would be a call option payoff and a long forward of payoff, which is just ST minus F and max 0 ST minus X. So that's how we change that if this were a purchaser hedging. And you can always vary to some degree the percentage that you're covering with forwards versus options and those unhedged. Also notice here I chose an out of the money strike, 75. Remember the spot price was 76. You could vary the hedge by saying, well, what would happen if they used a 70 strike? Notice the price of the option gets really cheap, but then you'd also notice when you run the simulation, it doesn't give you quite as much protection. All right, so that's how you could vary this hedging technique or the strategy. So that's it. In this topic, we have computed hedged and unhedged revenues using options and forwards.